And the first problem says solve. So we've got a little rational equation that needs solving. So, who's got an idea? Oh, please someone.
Get a common denominator.
Yeah, we're going to multiply through by the common denominator. So when I look at the problem, I'm going to multiply by whatever it takes to get rid of both of these denominators. So clearly, I'm going to need to multiply by an x minus 2 and an x. So everything is getting multiplied by x and x minus 2. Because that's what it's going to take to cancel this denominator and this denominator. So what's left? Well, let's see. If I do my distributive here, I have x squared plus x. And try to get in the habit of actually canceling out those things so that you don't accidentally try to include that x minus 2. It's gone. All you have here is x squared plus x. Now here we have x squared minus 2x. I'm going to distribute again. And then here I have a FOIL. So x squared minus 2x minus 2x plus 4. I'm going to close the door. I don't know if that'll help with the noise or not. All right, so let's look at what we've got here. Everybody okay so far? All right, so now let's just collect some like terms and see what we've got going on. Let's see. I'm going to go ahead and subtract this x squared over. So I think I only have one left because I have 2 of them here, but I'm going to subtract this one over. All right, so that's all done. Now I've got a negative x over here, but I'm adding 4x over here, so I think that's going to be plus 3x. If I add these over here, that takes care of all that. And then I'll just bring my 4 over. Remember, it's a quadratic equation. You want to have it set equal to 0. You do not want it to be set equal to 4. You want it to be set equal to 0. All right, what do we notice about that guy?
It factors.
It does factor. Now, there's no guarantee it will factor, but it does, so I will. But if it doesn't factor, what would I do? How would I solve that equation if it didn't factor?
Quadratic formula.
Exactly, quadratic formula. And you can use that anyway if you want. It does factor though. So my answers are -4 and +1. Now what do I have to be sure to do?
Plug the answers in the equation.
Well, I need to make sure I mean, it's always a good idea to plug it back in and check thoroughly, but really all you care about is, do either one of those make my denominator 0? So if I were to put in a -4 and or a 1, would I have anything to worry about? No, no. The only numbers that are going to cause me problems would be 2 or 0, right? They're not there, so I'm not worried about that. So my answers are indeed -4 and 1. Okay? Now, the next question on here is a little quadratic inequality. Oh, interestingly enough, it looks kind of similar to what we just had right there. How do I go about solving this quadratic inequality?
Subtract 4.
Yep, we want to get a 0. Anytime we have an inequality, we want to get a 0 over here because we know we're going to go to the number line and we're going to be shading positive and negative places. Or we're going to be looking to shade either positive or negative. So we've got to have a 0. This is negative now because it's less than 0. All right, what's next?
Factor the equation?
Yeah, absolutely. Factor it so that you know where to put the dots, right? So it's going to be minus 4 plus 1. So I'm going to have a dot at -1 and a dot at 4. Remember, the parentheses, the factors give you the dots. Now there is an or equal to on that problem, so I will have to color those dots in. Now I need to shade somewhere, and I know that my regions will alternate because my factors aren't squared or anything, they're just regular old factors. So I know that, for example, I could shade, not shade, shade. I know they'll alternate. I just have to figure out how to get started there on this shading. So what could I do?
You could plug in -2 for
I absolutely could. And I actually could plug in lots of things. -2 is a great choice. But as long as it's not a -1 or a 4, you can plug in anything you want. You want to plug in -2, I'm good with that. It is right here. Pay attention to where the number is that you're checking. You are checking -2, so you're asking yourself, do I shade this or not? Well, if I put in -2, I'm going to get -6 times -1. Is -6 times -1 going to give me less than 0? No, thank you. That means I do not shade, but if I do not shade that part, then I will shade this part, and I won't shade that part. Because the only time you're not going to alternate is if you have something like this in your problem. We don't have that, so I know my shading will alternate. So my answer is the interval from -1 to 4. Notice I'm using brackets because the parentheses, the dots are closed in. The dots are closed in, so I use a bracket. Okay? Now, on the back side, we have some more. So we have a rational inequality. All right, these are the ones that involve a little bit more effort. Caleb, I need your camera on, sweetheart. Thank you. All right, so what do I do here to get started? Please be careful.
Subtract the 1.
Yes, thank you. We subtract the 1. Remember what we talked about over there? We want a 0. If you're doing an inequality, you want a 0. Now what?
Common denominator.
Yep, we got 2 fractions. I'm going to think of this as 1/1. I have 2 fractions that I am subtracting. They must have the same denominator. So clearly, since that's a 1, the common denominator is going to be x minus 2. So I need to put an x minus 2 in the bottom so that now I can write 1 fraction with x minus 2 as the denominator. And then the numerator will be 2x plus 1, be very careful here, minus x plus 2. Then I can clean up that numerator. This is an easy one, x plus 3. Now, sometimes that numerator is a lot messier than that. So be prepared, maybe if you have fractions when you solve for x. But this one worked out great. All right, so now what?
Multiply each side by x minus 2.
No. You got to fight that temptation. We are actually done with all of the algebra. We go straight to the number line and we put 2 dots on the number line. Once you have one fraction, you go to the number line. We cannot multiply in an inequality by anything that contains an x. So where will the dots be on the number line?
2 and -3.
Yep. Just like you put them over here at 4 and -1, you put them here at -3 and 2. Do make sure you put them in the right order. Okay, now I'm going to shade. I got to figure out where to shade. So what would be oh, wait a second. There is an or equal to in this problem. What do I know about coloring in the dots?
The denominator doesn't get colored in.
Exactly. So the 2 will not get colored in, but the -3 will. X cannot equal 2. That would put a 0 in the bottom, which is not allowed. But we could let X be -3. That would be fine. All right, let's pick a number that's not these two.
0.
0, I like picking 0. For me, 0 is the easiest number. I like to pick it. Now 0 is in between here. So what I'm doing is asking myself, am I shading in between these two numbers? Well, what happens when I put 0 into my equation? I get 3 over -2. Is 3 over -2 bigger than 0?
No.
No. So I don't shade in there, which means I do shade out here, because again, the sections are going to alternate. So the minute you don't shade there, you know you're going to shade out here. When you shade in arrows, you know you're going to have infinities as part of your answer. So we have -infinity to -3. Let's use a bracket on the -3. And then, or we'll put our U there, a union symbol, to infinity. Notice the 2 is a parentheses because that dot, remember, stayed open. All right, any question about that guy? Okay. Now we want to know, what are the excluded values? Well, we already had a question like this on a quiz. Many of you did fantastic. Some of you were a little confused. Take a look at that wait, is there an X in there somewhere? Yeah. Tell me about the excluded values for this equation. None. Why are there no excluded values?
Because there's no X's in the denominator.
Yes, thank you. There is no X in the denominator, so there is no way the denominator could be 0. Excluded values happen when the denominator is 0. That's why 2 is an open dot. It's an excluded value. You don't have any X's in the denominator, you can't get a 0 in the denominator. All right, what about this one? Now, those of you that, when we had this kind of question on the other quiz, those of you that tried to solve that, oh my goodness gracious. That is not a wise use of your time. What are the excluded values? What would make the denominators 0? X can't be what? -2/3. X can't be?
-2.
And X can't be?
3 and -3.
Yep, 3 and -3, or plus or minus 3. That's it. We are not solving this equation. We are not multiplying through by the god-awful common denominator and getting some huge equation. We're simply saying whatever the answers are, They can't be negative 2/3, negative 2, 3, or negative 3.
Mrs. Ford,
Yes,
I have a question.
yes.
So for number one, why is it that we're able to cross out the denominator when we were adding, but for I think number 3, we weren't supposed to do that?
What's the difference in the setup of the problem?
Oh, yeah, right, sorry.
The
Yeah,
first
because
one
the
is an
equal sign
equals.
and then
That's
there's a
right.
big-
That's right. That makes all the difference in the world, because with equations, it doesn't matter if you multiply by a positive or a negative. If it's an equation, you can multiply both sides by whatever you want, and it's still an equation. But if it's an inequality, it matters whether you multiply by positive or negative, because you got to switch the sign. If you don't know if you're multiplying by positive or negative, then you can't do it, because you don't know whether to switch the sign or not. Right? All right, there's
Yeah.
going to be one more potential problem on the quiz, and which is not on the practice quiz. It is going to be a word problem, and the word problem will be either one of those where Susie and Billy are doing a job together. So, for example, I know it takes Grace 3 hours to clean her room. I know that if Jessica helps her, it takes her 1 hour to clean the room. How long would it take Jessica by herself? All right, so everybody knows what I'm talking about. What's the setup?
Isn't it like 1 over alone?
Yep.
Or,
So 1 over the first person alone plus 1 over the second person alone equals 1 over them together. So in this particular setup, I know that Grace alone is a 3, so I'm going to put 1 over 3. I have no idea what Jessica's time is, so I'm going to make that 1 over x. But I know that together, it takes them 1 hour. So these equations always look like this, because it's always 1 over plus 1 over equals 1 over. How do we solve it?
Would you multiply by 3x?
You absolutely would, thank you. There are other things you can multiply by, but 3x will take care of it for sure, because here the 3's will cancel and leave you with x. Here, the x's cancel and leave you with 3. And here we just have 3x. So solving, it looks like Jessica takes 3/2 hours, 1.5 hours to do the job. All right. Now, so the extra problem could be that kind. It could also be how much 18% solution needs to be added to 20 gallons of 30% solution to get a 25% solution. Okay, so there's the skeleton of the problem. I know the grammar's not perfect, but we've done these before. You know what's going on. I'm going to mix some 18 and 30 together to end up with a 25. So what's my setup for this?
Amount times percent plus amount times percent equals amount times percent.
Yep. So really, if you've been paying attention, these are so easy. Yesterday or one other day, whatever day it was, we did one where we didn't have percentages. we had dollar amounts. So we had stuff that costs $18 and stuff that costs $25, that kind of thing. The dollar amounts go in right exactly where the percents were. They function just like percents. All right, so let's see, I got 18% solution, I've got 30% solution, and I'm ending up with 25% solution. Remember, this over here is what you're ending up with. Now, I've got this 20 in here, and that 20 goes with the 30% solution. It says 20 gallons of 30%. So what am I going to put in this parentheses and this parentheses? Use your noggin. What are you going to put here?
Would you put X in the first one and then 20 plus X in the next one?
That's exactly what you would do. X really makes sense. How much? That's the question. How much? So we'll call that X. And then think about what you're doing. You're dumping in X gallons and 20 gallons. So of course your total is going to be X plus 20 or 20 plus X. All right, then we can use our calculator to help us. Find my calculator, here we go. And see what we come up with here. I don't know, I did maybe too much of that in my head. I got 14.29 gallons. Anybody match that?
I matched that.
Awesome, thank you. So we end up with 14.29 gallons. Okay, so our quiz on Monday, I will be posting an answer sheet. Please either print the answer sheet or reproduce it so you have something that looks like the answer sheet before class on Monday. I'll try to get that done either this afternoon or tomorrow. I'll get that on there for you. Okay? All right, so we got a couple of things yet to wrap up. So we're back now on this review packet. Well, it's not really a packet, it's a review sheet that I had given you before. And last time we were looking at the word problems, and we did the first 3 word problems down there, 7, 8, and 9. There's a couple left, so I'd like to get through these 2. Before we look at anything else. So I'm on the review sheet, the review 2.6 to 2.8, and I'm now looking at problem number 10 that says Pat's doing some soccer socks. Okay, he needs to sell, all right, and we know what is okay. All right. So who's got a thought about how we would start putting the pieces together in terms of an equation that we can solve?
Do we have to make 2 equations in this sense? So it's like one equation that like gets the cost. So it's like $5.75 X and then like $4.16 for Y, and then that should equal some type of cost, like this weekly overhead cost.
Okay, now you're on the right track. You're definitely putting all these pieces together, and I like your idea of basically he needs to end up with a profit of $10,800 because that's what he has to pay. Okay. And we know that profit comes from taking income minus expenses. So we need his expenses. We need his income minus his expenses to be $10,800. Would you agree with that? All right, how does he get income? He sells his
Sells the
socks.
socks.
Yeah. And how much does he sell his socks for?
His soccer socks are $5.75 per pair.
Okay, so 575x, if we let x be the number of pairs, 575x is how much money he's bringing in, right? Reed, I need to see your face, sweetie. So 575x is how much he's bringing in. Now, how much is he paying out? What are his expenses? What are his costs?
$4.16.
Yeah, so 416x, that's how much he's paying to make the socks. But there's more than that. What else does he have? Besides just the actual expense of producing the socks, what other expenses does he have?
Overhead costs.
Yeah. Every week he pays $3,850. So that's insurance for his employees. That's the light bill. That's everything else that goes into running his sock factory. There's your equation. Very simply, income minus expenses. That's what your profit is. And we know he needs to end up with this much at the end of the week. So we should be able to solve that without too much trouble. So if I haven't made any mistakes, he needs to sell 9,214 pairs of socks. Did anybody else get that?
Yep, I did.
Good, thank you so much. All right, and finally number 11, Sam's going to box up the socks. Her box must have a volume of no more than 100 cubic centimeters. Squares are to be cut from a piece of paper that's 11 by 16 with the flaps folded up. What size corners should be cut out? You know the drill. So tell me what our equation is going to be for this problem. Well, let's see. I'm going to have to call on someone. Hey, Zeus, are you there today? I see you.
Yeah.
All right. What's your equation going to look like, Jesus?
Isn't it just gonna be that one equation? It's like 16 plus like 2x, and then 11 plus 2x, and then x.
And that would represent your volume. And we want the volume to be no more than 100. So we need this thing to be less than or equal to 100?
Yeah.
All right, let's talk about that equation, kids. Is anybody bothered by it, or are we tickled pink with Jesus's conclusion?
They have to be minus 2x.
Exactly. Guys, remember, you are cutting the corners out. You are not adding them on, you are subtracting them. So 16 take away the 2 x's, 11 take away the 2 x's, and then x. All right, I'm going to graph this on my calculator. I'm going to choose to graph this side and this side separately. I have a pretty good idea what's going to happen. But when I set up my calculator, I'm going to set up my x's to be between what and what? What's my domain? X is going to have to be bigger than 0.
0 and alpha of 11.
Yep, so 5.5. And then my y's are going to be between 0 and, now I'm going to be graphing 100, so I might want to just put, 120 or something in there, something bigger than 100, because I know that one of my lines is going to be at 100. So here we go. Everybody should be typing this in, because we want to make sure we know how to do it when the time comes. Which you're all going to be calculus students, so the time is going to come for you. Now, using the setup that I did, my picture actually looks like this. Now, sometimes I would be concerned about that, because usually when I've done these problems, I've been looking for the maximum volume. So I have emphasized to you over and over again, we want to see the top of the hill. But in this particular case, I don't want to see up here. I need to see this part of the picture and this part of the picture. Would you agree with me on that? So my answers, I'm going to go ahead and find these 2 points. I'm going to go ahead and find those. That's where it equals 100. So having set it up this way, I'll do second calc intersect. And I got one of my answers to be 0.718. And now I gotta find the other one. And it is 3.937. Now your job is to tell me what size corners should be cut out. So in other words, aren't we looking for x? These are my x values. So tell me how I'm going to write my final answer. What's that going to look like?
It's going to be a negative infinity to 0.718 or 0.394 to infinity.
All right, let's talk about that. This is our first stab at the answer. And I understand that completely, because we're looking not at the part between them. That would be bigger than 100. We're looking at the beginning part and the end part. So that makes sense to me, but it's not right. Can somebody tell me what's wrong with that?
Does it need to be and?
No, actually, or is the correct conjunction to use in there. What does X stand for? X stands for what? In the problem?
The size of the box.
The size of the corners, right? The size of the corners we cut out. Look at this answer here. What did you tell me?
You can't have the negative infinity thing.
You can't have a negative and you can't have anything bigger than 5.5. So your answer is actually parentheses 0.718 bracket, because we can be equal to 100, or bracket 3.937, 5.5 parentheses. X cannot be 5.5 or bigger, because if it were, you would not have a box. You wouldn't have an X to cut out. So this was the right idea, but this is the actual answer. Does that make sense to everybody? Within the parameters of your domain. Alrighty. All right, let's go back and look at the rest of the sheet, and we'll use up the rest of the period. Let me see how much time we've got here. To do whatever other problems you want to do. I've done all the word problems. What other things on here look like they're things we need to talk about?
Six.
Okay.
Listing all the discontinuities and intercepts.
Okay. So 6 says, all right, we had a quiz like this. This is where you've got to draw all your asymptotes and all that stuff. So how do we start?
You have factor.
Yeah, I would factor everything, and the top I can actually take a 2 out of. So I got to keep the 2. You can't lose that. You got to keep that. And then x minus 3, x minus 1. And then the bottom's just the difference of squares. And right there, I can see I'm going to have what's known as a removable discontinuity. I'm going to have a hole. That's a removable discontinuity at the point where x is 3. So now I'm going to put 3 back into my problem. I got 2/3. Double check that for me. 3 minus 1 is 2. 3 plus 3 is 6. So I think I'm going to have a hole or a removable discontinuity at 3, 2/3. Everybody okay with that? Caden, did you shake your head no, or you got that? You okay with that? Okay, all right. Okay, what else? I factored now, so this is really what I've got left.
You gotta find the x-intercepts and the y-intercepts.
Okay, and they are other points, and they are found by letting x be 0, and then letting y be 0. So if I let x be 0, doesn't matter which one I do first, but if I let x be 0, I'm going to get 2 times negative 1 over 3. So negative 2/3. So I plot the point 0, negative 2/3. And that would be my y-intercept because it's plotted on the y-axis. Now, I'm going to let y be 0. Cross multiplying says 0 equals 2 times x minus 1, so I think 1, 0 is my x-intercept. When I solve this equation by cross multiplying, I get x equals 1. All right, so I've got my x-intercepts and y-intercepts. Okay, now what? What's still missing? Don't I have a vertical asymptote? That's called a non-removable discontinuity. I have a vertical asymptote at -3. X equals -3. And what about an end behavior asymptote? Look at my problem. You can look at the original or you can look at this one. Doesn't matter which one you're looking at. See how the powers match, guys? What does that mean? If the powers match, it means my end behavior asymptote is horizontal. Yep. So it's going to be y equals 2. The other quiz that we had, the powers didn't match, so you had to divide, and you got a slant asymptote. But here they match. So my end behavior asymptote is horizontal. And that's it. I put everything in there. I've got my asymptotes, my holes, my intercepts. So now I'm going to just connect the dots. And I think I got a lot of information here, so it's pretty obvious what it looks like, I think. That's part of it. Can't forget the other part, though. Where's the other part? Up here?
Across it.
Yep. Diagonally, catty corner from it. Yep, right up here.
So Mrs. Ford, when you say asymptotes and discontinuities, those are the same thing with the end behavior asymptote being a discontinuity?
Anything that breaks the picture is a discontinuity. Do asymptotes break your picture?
Yeah.
Yep. Discontinuous means you're not continuous. So that means you're broken. So anything at all that breaks the picture is referred to as a discontinuity. All right? You got time for one more. What's one more problem there you see? All right, let's just do number one then. What's the domain? What would be the domain of that rational equation? What do I have to think about whenever somebody asks me about domain? What are the things that go through my mind? Oh, you guys. Yeah. Who's saying that? You're right. Denominator cannot be 0. All right. So that means x squared minus 2 cannot be 0. Which means x squared cannot be 2. And x cannot be plus or minus the square root of 2. So that's the first thing that goes through my mind. When somebody says to me, what's the domain? The first thing I think about is exactly what you thought about. The denominator cannot be 0. What is the other thing that goes through my mind when someone asks me about domain?
Roots.
Yes. If there is a radical in my problem, whatever is under it cannot be negative. Now, do we have a radical in our problem? No. So I don't need to worry about that particular rule. It is always in the back of my mind. I'm always thinking about it when domain comes up, but it isn't part of this. So this is it for my domain. So how am I going to write my answer? This is basically what it is, but that's really not the way I should write my answer. Think about it. It's everything except these two numbers, right? So I'll say negative infinity to negative root 2, or negative root 2 to root 2, or root 2 to infinity. And that would describe every section of the number line, excluding those two values. Those are excluded values. Okay? Now, I'm also going to be, I've already posted the chapter 3 notes. I'm not here, or you're not here, for me to actually physically give you that. So you're going to need to copy that also. If copying the notes is, if you don't have the capability of printing the notes, send me an email and I will make you a packet, and then at your convenience you can come and pick it up from the front office down there. But you are going to need to print the next note packet because I don't see you to give it to you. Okay, everybody? All right, well, I think it's lunchtime, so you get to go have lunch. If you have questions, you come back at 2 o'clock, and I will be here. Have a great day.
Thank you.
Bye-bye.
Thank you.
Thank you.
Bye.